Hey guys, in this video I'm going to be explaining the data sections of your report and what you will need. So there are two main sections for the data, and that is your raw data and your processed data. Alright, so your raw data is the data that you collected on the day of the experiment in tables, both qualitative and quantitative. But before we do anything to it, so it is just the data itself. Okay, we just compile it all into a table and we attach that table. Okay, the processed data is when we take the raw data and then we build upon it and we analyze it and we create graphs and further tables and derive more information from it. Okay, so the raw data is quite simple. Alright, like I said, there'll be two sections of your raw data. There'll be qualitative and quantitative, and I have an example here to show you that. So this video essentially is just going to be showing you guys examples of what your two data section should look like, and then I'll make a second video explaining how I went about actually making that, and then you can follow along with me if you need to. So an example of the raw data. Alright, now I have used, this is the table that I have used, and I've actually provided you guys with both of these tables as a template up on my OneNote. If you are from a different class, you can request that of me as well. I can send that through. And essentially what I've done, this is just a random set of data. I've compiled all the data from my class, looked at who did things well, and chucked different groups data together to fill this up to get a nice clean looking piece of data, and I've chucked that into the table that I've provided for you guys. So it's nice and easy to read, time down the side, bit of title up the top, the different variations of temperature, 0, 10, 20, 30, 40, and you can see we did 3 trials for each of the different temperatures, so a total of 15 times conducting that experiment, and I've got all the data here as well. Okay, and that is the raw data. That's it. Okay, going down now to the process data. So I'll flick back to the scaffold. So that is now complete. We've looked at raw data. Okay, now you'll be looking at process data. So as the scaffold says here, there are 3 different things that we need to have here in our process data. So what we need to do now is we need to create a best estimate, so the mean, aka average values of each of the trials, and average all that out so we can get an overall value for each of the temperatures that you did, or concentrations that you did, or etc., etc. Okay, so the first thing is find the mean, the average of all of the things. The second piece of information we need to do is find the overall rates of reactions, and also the rates of reactions at each of those 10-second intervals. Alright, we can do that quite easily as well, just a little bit of work. And then the last thing we need to do with the data is calculate our absolute uncertainty and percentage uncertainty for the mean. So essentially that's just analyzing how precise our data is. So the quality of our data, how sure can we be that this is good data? That's the last thing that we're going to calculate. Okay, and we're going to put all 3 of these in tables, and then we're going to graph them as well where we can. Alright, so these 2 dot points here just says every time you put a table, make sure you have a table number and a graph description above the table. But if you're going to plot a graph, okay, each graph should have a figure number and a caption below the graph. Okay, so table above the graph, and graph table above the table, and for graph it'll be below the graph. Okay, so the first thing we'll go through is the mean, and I have an example for that as well. So here is the raw data. Now what I'm going to do is I'm going to take these trials and we're going to average them out. Okay, so essentially what we're going to do is for each interval, we're going to find the average for that interval. So we're going to find the average for that, the average for that, and the average for that all the way down. So essentially, we're going to turn these three trials into an average for all of the 0 degrees, and these three trials into an average for all of the 10 degrees. Okay, so we're taking our three trials and turning them into an overall average of one set of data for each. Okay, then we can very clearly and easily look at that and make an assessment based off how much hydrogen gas was produced without having to look at all the different types of trials. All right, so here is an example right here. So I've got process data, and this is my third table. So I've got table 1 and 2 up the top here. So my third table, table 3, and you'd have a little I haven't write one down because I'm not going to give you guys everything, all right, but you could write a little brief description here as well. So, a table showing the average or mean values of hydrogen gas produced at the various temperatures, something along the lines of explaining that this is, you just mentioned the main thing, you can mention that this is the mean values, the average values. So all I've done is I have averaged all of those trials out and got one set of values of data for each of the degrees. Okay, that can be easily done in Excel, and like I said, my following video I will show you guys exactly how to do that, but that is something that it will look like. Okay, and again, this template for this data table, I've put that on OneNote as well, so you can just plug it into that nice and easily. Okay, and I have graphed that as well. Okay, so that's quite easy to do. Just highlight it all and put it into Excel. And like I said, in a future video, I'll show you how I've done that exactly. But we want to graph this data, and here is a graph here as well. And you can see we've got a graph, so it's a figure and it's underneath the graph. So figure 1, and you have a little brief description here of what you can actually see in this graph. I've got a title, I've got axis titles, they're very important. I've got a key, okay, and I've got all 5 of those temperatures quite clearly graphed here on this. Okay, so like I said, this can be done in Excel. So we've got our mean values, and then I've graphed my mean values, and you can quite easily see what's actually happening in this experiment now. The 0 degrees took quite a long time to get going, and it didn't make very much, where the 40 degrees spiked straight away, it happened really quickly, and it also made quite a lot of hydrogen gas. So you can see that quite easily now with that graph. Going back to our scaffold here, the next thing that we need is the rates of reactions and the rates at each interval. Okay, so my next table, rates of reactions. Okay, now what I've done for each of these intervals here for the mean, okay, I've gone through and calculated the rate of reaction for it. Okay, the formula for rate of reaction is the amount of product that is produced, so the amount of hydrogen gas produced divided by the time taken for that to happen. Okay, so how I actually work that out is the difference between 0 degrees and, so 0 grams mils and 0 mils is obviously 0 mils, divided that by 10 seconds, okay, and that would give me my rate of reaction in this situation to be 0. All right, an example for, let's say, this one here, difference between 0 mils and 0.33 mils is obviously 0.33 mils, and divide that by the difference in time that took was 10 seconds, going from 60 to 70. So it'd be 0.33 divided by 10, and that would give me my rate of reaction for this interval right here. And if you just go through and work out for each of them, you will then get the rates of reactions for each of the intervals. Okay, now again, I will show exactly how I did that in the future video, and I've also taken all that and graphed it, and you've got the graph here. Same thing, average rate of reaction. So I've got the title, access titles, our key, and it all there as well. So that's these next 2 points here done, the rates of reactions, and I've graphed that as well. So the last we need to look at is the absolute uncertainty and percentage uncertainty. So a quick show you of what that looks like. It's a lot here. Okay, I've used this very similar table to the one from the top, and I've added in here I've taken the average values and I put in absolute uncertainty and percentage uncertainty, and I've worked these out. And again, in future videos I will show you guys exactly how I worked out these values. Alright, this is just showing you a heads up of what you need, what it should look like in the end result. As you can see here, I've got tables go on top, so this will be table 5, and you'll need a brief description here. That's obviously, this is my second graph, so you'd have figure 2. And after that, the very last table that you will need, just overall summary. So table 6, I've got the 5 different temperatures. I've got the final amount of hydrogen gas produced in mils in the average plotted out. I've got the absolute uncertainty done. I've got the percentage uncertainty, and I've got the overall rate of reaction of the different temperatures. So this is the final graph, and that is your data section. Like I said, I will do a video right now showing you guys exactly how I made each of these and what this all means, but this video should at least give you guys an example of what the end result should look like. Alright, it should look something along the lines of this with these different tables, and like I said, I will take the templates of all these tables and put them into OneNote, so you guys all have that, and you can just take your values and plug them straight into this while watching my other video exactly how to do that. So hopefully that helped, guys. Thank you very much.